All right. Before we start the lesson today, is there anything you want more practice with to do a math review? Is there anything you want more practice with to do a math review? Or do you just want to go straight into the lesson? Gavin? Okay, so you're going straight in. Everybody good with special right triangles? Everybody good with, how about this? Here's a warm-up. Sine. What is the other trig function that's related to sine? Cosecant, right? Cosecant is the reciprocal of sine. What's related to tangent? Cotangent, it's the reciprocal of it. And obviously then what's related to cosine? Secant, and the reciprocals. Okay, so remember that. Remember special right triangles. And then today, we're just going to do a bunch of angles. All right? So here's what we're doing today. Draw angles in standard position and find the value of trig functions for those angles. So you probably need a calculator at some point today. So have that handy. Get mine out too. And for right now, while we're working with trig, what mode does your calculator need to be in? Degree, right? So if you're using the one on your iPad, you need to switch it to degree. If you're using any other one, you need to make sure it's in degree. So let me get mine up here. Okay, so standard position and find values of trig functions for those angles. So let's just do a little bit of an exploration. Okay, for these four, find the value of x. Find the value of x for those four. Bless you. Find the value of x. (180 minus 45), 135. So it's 135 degrees. Make sure you use degrees. Let's see. This one is 180 plus 45. (180 plus 45), 225, 225 degrees. This one's a little tricky. It went through one full circle, and then it went 45 degrees more. One full circle has how many degrees? 360, and then add 45, 405 degrees. This one went 45 degrees less than 360, so 315, yep. Okay, so these are examples of angles of rotation. You have a vector and it's been rotated through a certain number of degrees, right? right? This one was 135. This one was rotated through 315, 405 degrees. Pretty straightforward. Is that good? Yeah. But we have to have down some definitions. Okay, so let's get these down. Because these are things, when I say them, you have to know, and you have to know how to, well, you have to use them when we take assessments. Right, so let's get this down. Standard position, initial side, terminal side. So you need to know what those words mean. Alright, so standard position, that means you're starting at 0 degrees. You're starting at the x-axis. Then you take this arrow, this is a vector, you take that vector and you rotate it counterclockwise. If you rotate it counterclockwise, then that means you're going positive direction. If you rotate it clockwise, then that means you are going negative rotation. Right? Where you start is called the what? Where you start is called the initial side. Okay? Where you end up is going to be the terminal side, right? Initial, if some of you are learning English, right? Initial, begin, terminal, terminate, ending, right? This is where you start initially, this is where you end or terminate. Okay? Those definitions pretty clear? All right. One more thing. You should paraphrase this in your own words. What is an angle of rotation? While you write it down in your own words, I'll just say what it is. It's an angle formed by rotating the terminal side and keeping the initial side in place. If the terminal side is rotated counterclockwise, like we just said, counterclockwise, that's going to be positive or negative? Positive. So when you go this way, positive. When you go this way, negative. So those are the big key ideas. Should probably draw this in for yourself before we do the next examples. It helps to have references when we're doing these angles of rotation. So if I draw an angle right here, how many degrees is that? 45, right? That's 45 degrees. 45 degrees. If I drew one that was up to here, how many degrees? 90, right? 90. So it's important to have these reference points, so let's write them down, what numbers they are, because we're going to use them in a second. How about that second black arrow? That one is how many degrees? 135? 135, and just fill it in so you know where you're at. This one is 180. Add 45 to that, that's 225. Add 45 to that. And you're at what, 270? Add 45 to that. 315. And then finally, same thing as 0 degrees is 360, right? Same thing as 0 degrees is 360 degrees. Okay, so those will help you when we do these angles of rotation in a second. Got those down? Okay, so why don't you try these examples? Draw these angles in standard position with the given measure. And when you do these, I'm going to ask that you do this, because it matters if it's positive or negative. You're going to show me which way it was rotated. If it's rotated that way, that's going to be positive, so you would put that kind of a direction. If it was rotated in a negative direction, you would show me this. Okay, is that clear? Okay, so you try it for those three. You try it for those three. $315 is right in the middle, so that means 320. I'm going to put myself a little anchor here. That'd be 315. So that means 320 should be a little bit more than that. And so when you do this on your assessment, that's what I should see. Negative 110. Well, let's see. This is negative 90. This one is what? Negative 135. So that means my vector should be somewhere in between there and there. Negative 90 and negative 135. So that means about right here. I went in a negative direction, so I show that. $990. Let's see. How many times does 360 go into 990 completely? 360, 720, and then what would come next? 1080. Okay, so it doesn't go into it 3 times. It goes into it 2 full times. Well, let's see. What's left over after you do 720? 990 minus 720. That gives me what? 270. So I need to draw an angle that's equivalent to 270. 270, we just saw, is right down the middle here, right? Yep. Now what you have to do to represent that it's 990 though is how many full rotations did you do? 2, right? So you would need to show me this. It went once, it went twice. Let's see, did I cover twice yet? Once, twice, and then the 3rd time around it stops right there. So do you see how that works? Yeah. All right. So we should be good with that. Okay. This is another definition. In trigonometry, we're going to have lots of new definitions. So, coterminal. Coterminal is a new one. So get that definition down. Angles in standard position with the same terminal side. For example, 120 and negative 240 are coterminal. So we'll see why. Maybe if you draw those for yourself, positive 120, and negative 240. You draw those for yourself and tell me why they are coterminal. So you draw those for yourself and somebody tell me why they're coterminal in your own words. So they're both in standard position, but they have the same terminal side. So let's see, 120. 90 is right here, 135 is right here, so 120 is about right here. That's 120 degrees. Well, and let's see, negative 240. This is negative 180. And well, let's see, if I add another 60 onto that, that would put me right here. So negative 240, the terminating side or the terminal side, is also that line. Does that make sense? So the words, think about it. Co means what? Together. Terminal means terminating, right? They end. Okay, so together they end at the same place. Coterminal. They both end at the same place. All right. Let's see here. 65. So you tell me, what is the coterminal angle? What is a coterminal angle for 65 degrees? So for 65 degrees, let's draw it first. 65 degrees is about right here. Now, if you want to know what's the negative version, somebody tell me a quick way I can do that. (360 minus 65), that gives me 295, but then I need to make it negative, right? So negative 295 degrees will terminate in the same place. Is that the only one? No. You can go another 360 degrees and you'd end up at the same place, right? Okay, so you could have either gone forward 360 degrees and you would have ended up at the same place, or you could have gone forward 720, or you could have gone forward 1080. So there's infinite many answers here, but this is one of them, and this is the first one. Okay. Let's see here. All right, how about 410? Let's do that one. 410 degrees. And I want a negative angle that matches with it. 410, so I went 360, and then I went 50 more. So that means I'm about right here, a little bit over halfway. 410. So that's the same thing as what? 410 is the same thing as what? Give me a number in between 0 and 360. First, let's start there. 50, right? It's the same thing as 50 degrees. You just did 410 minus 360. Well, so now let's go back to what India just said. What's the negative one that will match with that? What was your trick again, India? Make it negative. So that means negative 310 degrees will end at the same place. Does that make sense? Do you have any questions so far? Nope. How did I find 50? So this is over 360, right? So I already went 360 for one full rotation. Well, how much further did I go? Well, what's 410 minus 360? 50. Yeah. So that's how you want to do it. I think we can keep going. We haven't done too much. All right. Here's another important trig vocab word, reference angle. Another important trig vocab word, reference angle. While I get my screen back up, it's the positive acute angle formed by the terminal side and the x-axis. It's the positive acute angle formed by the terminal side and the x-axis. And that is the reference angle. So make sure you draw yourself a picture, because this we're going to use again and again. So tell me something about the reference angle. It's always going to be what? What's one thing you can say about it? Always going to be positive. Always going to be positive. What else can you say about it? Always going to be acute. It's always going to be positive. It's always going to be acute. And it's going to be formed by terminal side and the x-axis. Okay? Formed by terminal side and x-axis. Make sense? Let's practice it. Find the measure of the reference angle for each given angle. 135 degrees. 135 degrees. Well, let's diagram that first. Let's see, 45, 90, 135. So here is my 135 degrees. Now let's see. I want the reference angle. The reference angle is always positive. It's always acute. And it's always formed with the terminal side and the x-axis. So we're trying to find this angle alpha right here. So what is alpha? How'd you find 45? 180. Oops. 180 minus 45 equals alpha. So alpha equals, 180 minus 135. So alpha equals 45. Make sense? Okay. Well, let's see. How about negative? Because negative will probably throw some of us off. Let's do. Negative 105. Let's see, here's negative 90. I need to go 15 more, so that's about right here. Negative 105 degrees. So how am I going to find it this time? Say it again. Need to go backwards, right? Need to get to the x-axis, right? I'm trying to find this angle right here, alpha. Well, alpha, how much is the difference between 105 and 180? 75, right? Alpha equals absolute value of difference between, well, you don't need to say that. You can just say 180 minus 105, and you get 75 degrees. Go with that?
Why would it not be negative?
Oh, well, that's a good question. Because reference angle is always positive, acute. So this is how it's defined. It's going to take us 75 degrees to get back.
So it's just the number that has to be
Yes.
positive clockwise and
Yes. Yep. So again, it's always going to be positive, so you know you're not going to get a negative answer. It's going to be positive, and it's going to be acute. Okay, so last one. Let's just do some mental math for this one. 325. Let's picture in our heads where we would be And then what would it take to get back to the x-axis? 325. Picture in our heads. What would it take us to get back, Ceylon? 35? 35? People agree? 35 degrees. Alpha, reference angle, equals 35 degrees. All we did was 360, which is the x-axis, minus 325. So let's just recap, because I think this might be the end of it. Do we know what an initial side is? Do we know what a terminal side is? Do we know what coterminal angles are? Do we know what a reference angle is? All right. Let's see, this one. We'll do this one tomorrow. Why don't you start on the homework? Because you can see you have a lot of it. And actually, I'm not going to say evens because you all have been getting off too easy. 26 through 50. Okay? 24 problems. 26 through 50. And that one's due Friday. And so you'll try, see if you have any questions. Come back tomorrow with those questions. You won't be able to do all of them because we haven't covered all of it. This one is due Friday. Yes. Yep. Due Friday. Did you check the notes?
Just it said that we were having like a work day or something.
Okay. Did you check the video?
There's a video.
I post videos. Okay. So check those two things.